Okay, in previous video we saw how to convert an RGB color space to, or BGR color space to HSV. We also wrote a code for conversion pixel by pixel, and then we saw how can we convert using OpenCV. In this video, I'm going to show you that converting an image to hue, saturation, and value, we can detect a particular range of colors much more easily than otherwise. So we'll take a simple example of tulips image that we were using earlier, and we will convert that to HSV, and then we will detect all the red roses, for example, the roses or the colors that are red there. So let's do that. First of all, again, let's go and read our image. Control C, and so image is CV2 imread, and that's our path. So we read that image. We can show that image using Matplotlib or OpenCV as earlier. So let's show that image using Matplotlib image. Just convert the colors space to consistent with that. So our goal now is to detect all the roses that are red or that has more red. We want to segment out the red roses here. So for that, let's convert the image to HSV. So HSV image is cv2.cvt color, and we have our image, and then we have cv2 color bgr to HSV, and that command will convert the image from BGR to HSV. Now we have hue, saturation, and values. It turns out that in the red color represented in hue, saturation, values has two different ranges. So the lower red color is basically np.array. The lower red color can be represented, the hue value is 0. It is basically from 0 to 30, but let's take a 0, 120 for saturation, and the value or the brightness is 70. So next we have upper red color is np.array. So again, we can have the red color has a range between 0 to 30. So let's take 0 to 10 or maybe 15. And we have saturation values for 255 and the brightness values 255. Now this is one range for red luminance. Maybe we can change this hue value from 0 to 10 or 0 to 5 to become more sensitive, or maybe 0 to 30 to pick more range. But let's build a mask here, mask 1, which is cv2.in range HSV, lower red, upper red. What this function will do is it will give you a binary mask. So for example, if we see the type of mask 1, it is ND array, and if we see the type of mask1.d type, it is unsigned integer 8, and all the values inside are basically, if we see the values inside, for example, mask 1, so let's see the shape of mask1.shape as well. The shape is 638 by 640, and the values are mask1.max value. Let's do that. That is 255, and mask1.min value, that actually gives a 0. So basically it picks all the pixels that are in this range and discard all the other pixels. So the pixels that are in this range, they are picked, and the pixels that are not in range, they are not picked. So basically that's what this in range function does. Then we can have another range of the red values. It turns out the other range is between 150 to 160 for red values. So let's have another range to pick both. Yes. So the other range is basically if this is, let's say, 160 and the other things are same and this is 180. So that's another range. We can build another mask, mask 2, exactly like the same. So the hue values and the saturation and the brightness value stays the same, but the hue values has two different chunks. One chunk is between 0 to 30, and here we code it as 0 to 15, and the other chunk is 150 to 180, and we just picked 162 or 165 to 180. And then we just pick the in-range values, HSV lower range and upper range, and let me call that as mask 2. Now if you see the np dot unique values in mask 2, you will see the unique values are just 0 and 255. 0 means not present, 255 means present. Similarly, the unique values, for example, unique mask 1, if you see that, that is again 0 means not present and 255 means present. We can convert these to Boolean arrays as well if we want, to convert 255 to true and 0 to false, and then we can take a bitwise or we can directly take a bitwise or, because 255 or with a 255 will stay 255 and 0 or with 0 will stay 0. So let's take an or mask. The final mask is mask 1 or bitwise or mask 2. It may seem confusing because mask 1 and mask 2 both are not Boolean arrays, but we can convert them to Boolean arrays, or taking the same will stay again the same, because 0 or with 0 will stay 0 and 255 or with 255 will become eventually become 1. So now if we see the unique values, np.unique values of mask, we can see the values are 0 and 255 because 255 or 255 will stay 255. So now we have our final mask. Now let's compute the resultant image. Resultant image is cv2 dot bitwise, and we take our image, original image, we take the two arguments, and we set the mask equals to mask that we have computed. That's our resultant image. By just picking those pixels for which the red color is 255 or on. Next we actually display this image along with the original image. Let's display that. So plt.figure 1, plt.subplot 1 to 1. We have two figures, two subfigures, and the first figure is plt.imshow img. Remember that has to be converted. That's our original image. That's our image, original image. And now we are going to show plt.subplot 1 to 2 plt.imshow our result, and the result needs also to be converted from BGR to RGB, and then we say plt.show, and hopefully it should detect the red colors. As you can see, the red colors are detected somewhere. The yellow colors are also detected. You can become more sensitive in these thresholds to become more sensitive to red color. For example, you can go to, for example, 0 to just 8, just taking an example. And you can go to, for example, this from, let's say, 170 to 180 to become more red color sensitive. And here, for example, you go this. and maybe you get more reddish color out. And now you can see the segmentation is, if I want to pick another particular color, maybe I change the ranges, and it turns out you can also play with that. It turns out that if you do that in RGB image for general kind of images, it may not be that handy to segment out different kind of components that easily. However, in HSV and in other color spaces as well, particularly in HSV, segmentation of different color objects, even with a little variation on that color, becomes much more handy. And later we will see that object tracking, different object detection and tracking, that may also become handy using histogram of these HSV color spaces and stuff like so. So hopefully you have enjoyed this color segmentation or object segmentation using this HSV conversion. In the next video, I'll talk about the hyperspectral images, the images with more than 3 bands, more than 3 channels. So hope to see you in the next video.